Alright, hi year 11s, this is Mr. Lim here again, and this is our first video on chromatography and gases, just an introduction to chromatography. So let's get started. Alright, so we're going to be learning a couple of definitions and then work out how things move through these stationary phases within the chromatogram. Alright, let's get started. Okay, so let's have a look. Chromatography is the separation of mixtures. Okay, so we're separating stuff, or mixtures of stuff, as they move through a substance known as the stationary phase. Okay, so the mixtures of substance is usually dissolved in another substance known as the mobile phase. Okay, so what that means is that, okay, we've got a stationary phase, which is something that doesn't move. In this case, we're using these little red balls here to identify things that are stationary phases, okay? So this could be a piece of paper, it could be a special tube filled with stuff, all right? But the ultimate idea is that that stuff doesn't move, right? Then you take your mixture of substances, which are represented by these two little bits and pieces, these two dots here. They are two parts of a mixture, okay? And then they're dissolved in the mobile phase. Now in this diagram here, the mobile phase is this rectangle, which effectively kind of goes through the stationary phase as well. So in reality, this mobile phase would be made up of lots of little bits and pieces, right? Lots of little different molecules. It'd be effectively the solvent, which is a substance that you dissolve stuff into, right? And then it would move through the stationary phase as well, all right? So let's go back. Okay, so the components of a mixture, the different parts, which is the little green and blue dots, have varying affinities to the stationary and mobile phases, meaning they will stick and release from them at different rates. Okay, so for example, this green one here, we're moving through the mobile phase and then it will stick to this little thing, this stationary phase, right? And then it will come off, right? So we call this absorb, which is where they stick to it, and desorb, which is where they come off it, right? And then we'll go to the next one, absorb, then desorb, then move through, absorb, and then desorb, all right, as they move through the thing. Okay, this one here might go a little bit slower, so it might get stuck here, and then it will stay there for a while, and then it will come off, then it will get stuck there, will stay there for a while, and then it will come off and get stuck there to stay there for a while. So ultimately, these two things eventually move through the stationary phase, right? So the rate at which they stick to the different phases determines the rate at which they progress through the stationary phase. So the stationary phase is the entirety of all these little red dots, and how fast they move through them is dependent on how much they stick to those stationary phase red dots, okay? And this means then the different rate of movement allows the substances to be separated over time. So we're going to go through that idea in a bit, okay? So another example how we might describe this is how we move through shopping centers. Right, so in this example here, the woman goes through and checks out every shop, right, but the man just goes straight through to the one shop and then in and out. All right, so you might call the different shops the stationary phase, all right, and you might call the man and the woman the different components of the mixture, right? The woman here, in this case here, goes and sticks to the stationary phases, which is the shops, and spends a lot of time in there and therefore moves through the shopping trip very slowly, whereas the man only sticks to it once and then goes straight through, doesn't spend much time stuck to the stationary phase and moves through it reasonably quickly. All right, but that's a bad example. Let's just go through it again, making sure we have a good idea of how this works. All right, so, okay, so mixture of components, right? Some have a strong affinity to the stationary phase and thus spend the majority of their time stuck to the stationary phase and not much time in the mobile phase moving. So they will take a longest time to move through the stationary phase. All right, so we're going to use the blue one here. So the blue one stuck to the stationary phase for a long time. Okay, so it stays there, then it moves to the next one, then it moves to the next one. Okay, but it stays stuck to the stationary phase for a long time, and therefore it takes a very long time to move through this thing. So we might say, okay, this one gets stuck there for 5 seconds, right? Then it moves to the next one, gets stuck there for 5 seconds, then it moves to the next one, gets stuck there for 5 seconds. All right, so that's that blue one. right? Then some substances have a weak affinity to the stationary phase or a strong affinity to the mobile phase, and thus spend very little time stuck to the stationary phase and more time in the mobile phase moving, and these particles will go through the stationary phase very quickly. Right, so this will be the green particle. Maybe this one will totally skip that one because it doesn't have a high affinity to it, right? And it will get stuck there for maybe 1 second, then move through, get stuck there for 1 second, and then move through and keep on going. All right, so the idea is that by the time that this green one has moved through the entirety of the stationary phase, or this part of the stationary phase at least, all right, this blue one is probably still stuck to the first one because remember I said that, this one would be stuck there for 5 seconds. So that whilst that one's stuck there for 5 seconds, this green one has been like, I'm skipping you, only to get stuck there for 1 second, get there stuck there for 1 second, and then all the way through. And so therefore, the idea is that this one here, this blue one, has moved very little, and the green one has moved a lot in that same amount of time. Right, and therefore the green one is moving quickly, the blue one is moving very slowly. Right, so then if we can then, if the components of the mixture are ranked by their speed through the stationary phase, inferences can be made about their affinities to the stationary phase and mobile phases. Right, so particles that move quickly through the stationary phase have a low affinity to that stationary phase, right, and a high affinity to the mobile phase. And then particles that move slowly through the stationary phase have a high affinity to that stationary phase, and therefore a low affinity to the mobile phase. And therefore, you could say that the speed through the stationary phase is inversely proportional to the affinity to the stationary phase. All right, so let's have a look at these couple of examples here. All right, so this here, what's happened here is that they've put the mixture of components down here. All right. Then they've put, this is a piece of paper, they've put it inside a mobile phase, and the mobile phase has forced them to move this way up the stationary phase. The stationary phase is like this rectangle here, right? So this red one here has moved the furthest from the original spot there, right? So the red one, in the same amount of time, because that's kind of important that these things move, this particular picture is a point in time where they've all spent the same amount of time in the mobile phase or going through the stationary phase. This red one has moved the furthest, which means that it's going at the fastest speed. All right? And so therefore, this red one has the lowest affinity to the stationary phase. Which one has the highest affinity to the stationary phase? Then the yellow one has the highest affinity to the stationary phase because that one there is stuck and keeps on getting stuck to the stationary phase. That's why it hasn't moved very far. All right. The other example here, okay, over here, this green stuff here is the mixture. It's actually made up of an orange and a green sample. Okay, so these orange and green are the two components which is inside this mixture here. When the mobile phase is added to it and it's dumped in, okay, so that it will just start to dissolve, these will flow through that stationary phase. But as you can see here, the green is starting to move through faster than the orange. So which one has a higher affinity to the stationary phase? The one that is moving slower through the stationary phase. Which one is moving slower through the stationary phase? The orange one here is moving slower because it's traveled only this far compared to the green one, which has traveled that far. So the orange one has moved slowly through it, the green one has moved quickly through it, and therefore is going to, the green one's going to come out first, and then the orange one will come out later on. All right, what's this blue stuff over here? It's the mobile phase, which is still kind of moving through as well. All right, and the mobile phase will generally gets through there faster than the substances there. All right, so that's the idea, that they move through at different speeds, right? And the speed at which they move through gives an indication of the affinity to the stationary phase. So in this case here, the top case, red has a low affinity to the stationary phase. Yellow has a high affinity to the stationary phase. In this case here, the one that comes out first has a low affinity to the stationary phase, and a high affinity to the stationary phase is the orange one, which moves through it slower. Not to say that it won't get through eventually, but it just takes more time to get there. All right, and that's the introduction to chromatography. Adios.